thank you for coming back. Cheers to the continued support, obviously, with Mobile London. Really good to see sort of similar names coming up each sort of week or every couple of months when we host this now. Yeah, good to see you guys still attending. As always, this will be recorded, so if you'd like to share after, or with a colleague, friends, or if you missed part of it, feel free to watch that back on our YouTube channel. I'll put the links on our meetup group. But yeah, no, apart from that, thanks to Michal for taking the time out today. Michal's the mobile lead at Navico, and yeah, he's got an interesting topic to share with you guys. So yeah, over to you, Michal.
Oh, okay. Hello, everyone. I'm Michal Paszkiewicz. I'm a mobile technical lead at Navico. And I'll be talking about some of the technologies we use in our app development. If you have any questions, please post them in the chat during the talk, and I will try to answer them as we go. Okay, so I've called this MapBox Mobile Maps Mariners, and that's what we're talking about. We're talking about mobile maps apps that are for sailors, for fishermen, and anyone else going on the water. So the marine space is quite an interesting space in the developer world, because we have a lot of problems that are slightly more exaggerated in our space than in other spaces. One of them is distributed computing. We have a very distributed system where we have many different devices across the world. We have these in offices, we have things in the cloud, we have machines on boats and on apps that are likely to be offline the majority of the time. We have a big problem with dealing with battery life. People who are sailing don't want to lose their battery. This could be a big issue if they are using a chart plotter or a mobile app for to try and see where they are. There is an issue with poor internet connection. People on the coast are unlikely to have a very good internet connection. We have a problem with data quality. A lot of the problems with data quality are that there is just not enough data on marine areas, and that is something that continually improves. And trade laws. Dealing with charts between countries can mean various things. One of these is that it's actually counted as an export, so it has to be taxed, and various countries have different laws for how maritime data can be shared or used. In terms of distributed computing, the fact we have devices that are very partitioned, let's say, we do not have the option of having both consistency and availability, and we have to make choices between these continuously. And actually, a lot of the problems we have are, in a sense, the sort of old-fashioned problems of a back-end developer rather than a front-end developer who just wants to display things. Although this may be more common for mobile users who are now often, or mobile developers who are developing things that are likely to often go offline, especially if people are developing in cities like London, where people are using the mobile on the tube and they may be underground for a lot of the time. Data quality is a big issue. Some of the latest techniques, like multi-beam bathymetric data, it's only been used on about 12% of UK waters. There are surveys with other techniques, but they are stale, they are old, they are not across the whole board of water. Some water is difficult to get to, some water is not deemed useful to survey because there's few people there. And the staleness of data is an issue because what happens is underwater surfaces always change. The seabed, the river bed, the basins of lakes, they all change continuously, and you need to remap these over and over again. This is quite a big issue. And different hydrographic offices provide different data. So part of what we do is we combine hydrographic data, and this can be from a variety of hydrographic offices, and it can be quite difficult to ensure we have the same quality of data across areas. So who are Navico? We are a company that specializes in marine electronics and software specialists. We don't just do mobile apps. We do sonar, radar, chart plotters. These are devices, sort of tablet-like devices that go on your boat and allow you to look at a variety of data to see where you are, to help you move across the water. These are legally allowed to be used as routing devices. So you can use these to find your way across the sea, across lakes, and they're really good pieces of equipment. Unlike the mobile apps, which are supposed to be used for planning, I'll get to that later. But we do other things, both IoT, so various sensors, various devices that go on boats, including motors. We have a great trolling motor. We have autopilots, these sorts of things, and mobile apps. And this is where I fit in as a technical lead in the mobile space. I work on the mobile apps. So what do we do in the mobile space? I actually have I actually work on a variety of apps, and I've highlighted them here. We have CMap, which is the standard app for looking at charts. And there are 3 that are similar: Lowrance, Simrad, and BNG. So Navico has brands that are multiple brands that are sold to different kinds of customers. So Lowrance is for fishermen, Simrad is for cruisers, for people on motorboats, and for people who just like getting on a boat and going out, and BNG, which is for sports sailors. And each of these apps is like the CMap app, but with specialist features designed for those particular users. And they're called companion apps because they interact with our MFDs, the chart plotters, these things here. And these are the devices I talked about. These go on your boat, and they describe what's where you are, and you can look at your sonar and your radar data on these, and the interaction between this and these are vital for how we function. We have various features that allow interaction between them. For example, one of the latest ones is we can mirror what's on your chart plotter on your phone, which is quite a useful feature for boaters who, for example, leave their cockpit. They go up front, but they still might want to see where their map. They might want to see what the sonar's seeing, and they can do this on the app wherever they are on that boat. We have Boat Connect on the bottom left here. This is for interacting with your boat. You can have various sensors on the boat, and you can check whether your boat is within a certain area. So if someone's stealing a boat, you'll see where it's going. You'll see someone's stolen it. We geofence it. We have a depth water sensor, and so we can we call it a bilge sensor. So it checks if water's leaking into the boat, and we can check if someone has opened the hatch, and these sorts of things. So we allow interaction with your boat and that distance. So when you've left your boat, you can be sure it's safe and nothing's going wrong with it while you're at home or anywhere around. And on the bottom right here, we have Fish Hunter, which is an app that's specifically designed for looking at sonar for with this Fish Hunter Pro device, which you'll see here on the bottom right. So the Lowrance Fish Hunter here, this is a little device you throw in the water. It uses sonar and can detect where fish are in your water, and then you can see this on your app here, which is a very cool device. But I'll be talking primarily about the companion apps and the CMap app today, in terms of the technology we use. Let me move on to the next bit. One thing that's important for us is that we work not just with mobile, but with a whole ecosystem. What does that mean? So that means that we have not just a mobile that we're working with, but we actually have multiple things that there are multiple devices on which users work or might want to access their data and plan their trip and go on their trip with. So when they're at home, they might be planning with their PC or laptop. When they're on the move, they might want to look at their plans with a mobile. They might want to also glance at things while on the boat with their mobile if they're not at the cockpit. And when they're on the boat, they generally will use their chart plotter as the main device. But the mobile provides the interaction between chart plotter and wherever they are. So the mobile has a space in a broader ecosystem. And what this means is that is that we are also we also have to support other things. So one of the things we support is the web apps. So in the mobile team, we don't just do mobile, but we also do the websites, and we have an equivalent for each app. So there's the CMAP, LowRant, Simrad, and BNG apps. Now, why do I mention all of this? Well, I'll come back to that later, actually. But what links all of them is we have one single sign-on now, and we can log into all of these in one, and we're trying to improve the experience of the connected system. So anyone interacting with any of our devices, any of our apps, they will be able to log in with one account, and so they can start to see this ecosystem be something that they are involved with. So it's not just a bunch of disconnected devices and apps, and this is quite exciting. What sort of things do we do in our apps? So our charting apps have to provide a variety of features. One of these is we see you need to be able to create a route. You need to be able to see what's going on. On our app, we see things like recs. We have the depths. We have names of various areas. We have areas where you can anchor, and buoys, lights, all of these sorts of things. We need to provide a night mode. If you're sailing or out on the boat at night, you don't want to ruin your night vision, so you want to see everything in a darker mode. And we need to be able to provide to download data, so that when you're offline, when you don't have internet connection, you can still look at your data and still continue being on your boat and being safe. Now, an important part is that the mobiles aren't actually licensed to be used as your main form of navigation. So this is just mainly for support and for planning, and it's expected that they are used in conjunction with either a chart plotter or paper maps. But when you're in the water, which can be quite unforgiving, you want to use as much data, as many sources as possible to make sure that you are safe. We also have interconnected this with nearby data. So on the left, we have AIS data. You see here, these are 3 different boats that were nearby about an hour ago: Siegfried Lehmann, Estuary Escort, and CC Fort Fleur de Paix. So you can see what's near you. This is important so you don't crash into other boats. AIS is a data source that's necessary for boats over a certain tonnage, so you'll definitely be able to use this to avoid big boats. And sort of more on the pleasure side, we have a cruising guide that will look at nearby data and try and help you select where you might want to go, or what places are worth visiting. You can add your own places, your own routes, and interact with the map. I imagine many mobile users here would have tried to work with localizations, and this can be a nightmare and can be difficult to do. And we not only have to support languages, but also different units for depth, for boat speed, for coordinates. And this is something we have to think about. We have a variety of different topics we have to stretch across in order to be able to provide something that's useful for our customers. Another thing is we differ quite a lot from land mappers. If you think about Google Maps for just driving, and that there's a lot more things that are important for a mariner. For example, weather is vital. You don't want to be sailing if the wind's too strong, and if it's too weak, you're just not going to sail. So we need to provide weather data in addition to just a map. And we can see here there's weather, there's tides, and waves and currents. And on the right here we see one of the latest features we've put in, which shows weather along the route, which is a way of displaying what the weather will be like when you get to a certain point. So what we actually have is I selected 2 points, and we have an auto routing function, so it automatically selects the route you should take. You can see that it does provide caveats. It says here you've got to be careful. You can only do this at high tide. Same here, and then you can look at your weather data to see. Well, it will calculate what time you should arrive at each point if you start at a certain time, which you can select with the scrubber here. And then at those times, the weather is queried, and you can check what the weather will be like at various points. And if one of these was pouring or really high winds, you might want to not pick this time, and you could try the scrubber for a different time to make sure you can pick a safe time at which you'll be able to depart. So why do we use React? So we have a situation where we have to be very cross-platform. Not only do we need iPhone and Android, we need web as well. And React is a really good, React and React Native allow us to do this quite easily, especially when we interact with MapBox. But we can share our business logic, and then the front end is quite easy to share between these, which isn't entirely possible with something like Xamarin, for example. Other JavaScript technologies are possible, but we found React to be the right thing for us for a variety of other reasons as well, such as the event system makes it with Redux, makes it quite neat to work with our logs. So we can use analytics from these events to figure out what's going on and diagnose any issues for our customers. And this has proved really good, and we're very happy with React and React Native. We do have various technical challenges all the time. One of these is, for example, migrating to TypeScript. As you can see here, in the span of a year, we've got from a huge code base in JavaScript and a bit in Objective-C to about just over 35% TypeScript. And there's a continual amount of work to be done in technological challenges, in developing, in upgrading libraries, in moving to TypeScript, in making sure we follow good code patterns and keep our code clean. So we certainly have this, and React works really well with TypeScript. We're very happy with that, how that works as well. Let's see what's next. So what do we use with MapBox? So our MapBox stack looks like this. We've got a GDAL toolset for processing data. One thing about GDAL is I highly recommend never using it directly. It can be difficult to install on almost any device. So the way we generally do it is, I'll show you, is we have a Docker image. Where is it? Docker file. We just use an OSGeo GDAL image, which is nice and easy. You have a Docker file, you can spin it up, and it has everything installed with regards to GDAL on it. And I highly recommend this for anyone working in GIS, because frankly, I've tried it on 3 different machines, because we use Linux for hosting. I have a MacBook for work, and I have a PC at home, and installing GDAL and other GIS technologies on these is an absolute nightmare on any of those. And some of them are worse for one and better for the other. But I found that if you want to work with GIS generally, it's much easier to have Docker images for all of them that you work with. MapBox interacts best with MB tiles, which is a very user optimized format. It divides everything up in tiles as you write to it. And that means that when you query a MB tiles file, which is actually a SQLite database, it will return exactly the data you need for your map, for the image you're actually looking at, for the area, the location on your map. We use Mapnik for serving the data on the back end on the API. And then for the front end, we have the standard MapBox libraries and React Native MapBox GL for mobile. So React Native MapBox really adds, really simplifies the interaction with MapBox on a mobile, and I'll show you that. This is the sort of thing that's given on the tutorial in terms of how you interact with MapBox GL. And it's a simple case of having a component, MapBox map view, and then having styles and everything. And the majority of development with MapBox happens in the styles side. If you've got the right data, you can easily update the styles, and that's what gets you your data up. So if we look at in here, for example, I've got star. So this is the web equivalent. On the web, if you don't use the React Native MapBox, you use the standard MapBox GL.js library, for example, and it's a case of chucking in a MapBox map, and then providing a URL for the styles, which is here. And then if I want to have a new set of data or anything, I can just update this JSON file. So if we look at what we've got here, so in this file, I'm adding a land area, some OSM place town labels, and this is you'll see the type is a symbol. It comes with a text field, a font, a size, which can change depending on the zoom level. A minor label, which is the same, but for smaller areas, and labels here again, and a symbol with an icon, for example, where we can have an icon image, which we can get, and that will come from the top here, which is a sprite. So just an image with a variety of images on it, and we can select an image according to that. So if we look at what this file creates, we see here we've got the country names, we've got the land area. This is what the first thing was, and then when we zoom in, the icons that we're showing should show us, oops, the recs. So here we have recs. So it's in the development actually becomes really easy with MapBox, and the beauty of it is how easy it is to put in both the web and in React Native. So if we look in our code, this is where we put MapBox map view. It's very nice and simple. You put in your parameters, your style URL, which can be your JSON, and you can develop with that JSON. And then you have a few options that you can put in a camera or other sort of adapters to change that around. So I highly recommend MapBox. It's really easy to interact with, and I would say more fun than working with your Google Maps API. And gives you, I think more options with what you can do. So yeah, it's very exciting, and a lot of data is available. If you look at things like OpenStreetMaps, you can get some data to start you off with, and then start working with this. So going back, so what is the future in the mobile space? So there is a big difference between land maps and mobile charts, and it's not surprising considering apps like Google Maps and its predecessors of Google Earth and are quite a bit older than interactive web and mobile maps. They have better data. They are able to get satellite imagery, and they can get that fairly regularly with their satellites. You can't get something, a solution as good for the sea, because obviously you can't take photos that will penetrate the waters as well. Generally, if you want good bathymetry, you really need to get up close and do it from a boat. There's open source collaborations with things like OpenStreetMap, and many companies can benefit from this. Apple Maps famously uses some of OpenStreetMap, and then adds their additional data on top and styles it accordingly. There's location imagery, so you have Street View, and Google are very nice in that they subsidize all the royalties, which they must pay a lot of, so you get free maps. This is not quite as possible for us or for our competitors, and the amount we have to pay hydrographic offices across the world to be able to present this data is just unsustainable to provide for free. So people have to pay premium to be able to access some of our more accurate data. Land maps are generally really well linked to devices, so you can nicely put your phone in your car, and you can immediately start having calls through it. You can look at your map on your car and interact with the map in your car, which is really cool, and that's something we are developing. Well, we have the chart plotters on boats, but it's not quite the same experience interacting with your mobile app as it is in a car, for example. Land maps are available on any device, so I mean, the fact it's so easy to get on a browser or on your phone, on a tablet, and you can go on the browser on your Xbox and look at a land map. It's really nice and easy, and it's very intuitive. And they've been able to do that through the fact that so many people interact with the land maps. So there's a lot of opportunities in the chart space in the marine area. There's things like social data, which is the equivalent of OSM, which we're doing with CMap Genesis, which is a project where we are allowing users to upload data from their sonars and share it. And this is really useful because obviously this will be more up to date than a survey that may have happened years ago. We can get data as soon as anyone's been on the water, and the more people are on the water, the better the data, which means that areas that are more used are already likely to be getting better data, which is really great. And we are working on interactions with devices on the boat. So there's a lot of opportunities in autopilot space, for example, where if you auto route on your phone, you should be able to connect this up to a motor and just let it go for you, right? That would be great. And this should be more possible on a boat where you might not have to worry so much about the handling, although you do have to worry about observing, in the sense that sometimes there might be things in the water that you can't expect, a floating log, a coral reef that the hydrographic office wasn't aware of, and these things. So there are obviously worries with autopilot, but there are also many opportunities, and interaction with more of the sensors. So there are in the modern day boating world, there are many sensors, and they all interact nicely with the chart plotters, but not so well with the mobile devices so much. So there's a big opportunity for improvement there, and more display of data. There's obviously many opportunities with getting more data that fishermen and that sailors are interested in, improvements in auto routing, something that's still not entirely solved, and it's very difficult to do auto routing correctly, because boats, if you want to, for example, start looking at really detailed auto routing functions for a boat, you'd have to start looking also at what kind of boat it is. If they're a sailboat, you have to provide tacking information. So if they're going upwind, they need to change direction regularly so they don't crash into whatever's on the sides, and so that they can go in towards their actual destination. And the sort of the speed of the boat will change on the boat type and the sails it has, and all these other things. So there's a lot of research to be done there. So I also wanted to talk about just how we work, because there are obviously an absolute humongous amount of pieces of work that could be done to improve our apps. I hope some of you download the apps to have a look. They are free to use with the basic features. They are free to use, so you can have a look at them. And you'll see that there is certainly a lot that can be improved, a lot of features that can be added, especially if we compare ourselves to big map providers like Google Maps. So we have to be very careful and wise in how we pick the work that we do, and we do this in a very user-driven way. So we use analytics from our well, essentially our Redux actions go straight into our analytics, and we can see what people find useful. We can see, we also test the mobile apps. So whenever we release a feature, we'll have a time where after using a feature, they'll see their little icon saying how happy are you with this feature, and they can select a happy face or a sad face. And if people are liking a feature, we know that's a good piece of work and that it's an area that people are enjoying, and we might want to improve on that. And we use surveys that go directly to our users, which are frankly the most useful. We can find out what people want, what they need, and we try to drive ourselves in this way. So quarterly, we'll have a KPI-based brainstorming session where we'll take into account everything that everyone's said, and we'll try and identify a few areas where we can improve in, and we'll set these as sort of frameworks and then try and improve on each of those things specifically by coming up with ideas that could be dealt with. Then we try and prioritize them according to how important they are. And then at the end of the day, we go back to our users and we try to get some surveys on what they think of our ideas. When we release features, we might have a few options, and we will use analytics and our tests to see. We do some A/B testing essentially to see what versions of features people like, and that's how we move forward. So I think that's quite important for the development process. And we try to stay agile, but we generally don't follow a very rigid principle, which I guess is how we stay so agile. We have our KPI quarterly meetings, but we also have feature-driven development. So this means that our developers get involved early on and will drive a particular feature by themselves. And we found this really useful to get developers involved early and know exactly what they're developing and involved through the whole life cycle. We have our daily stand-ups to make sure no one's blocked, and we keep everything on the Kanban board so we can figure out what's going on and prioritize any work coming up. So that's pretty much it. I have a few questions. I have a question: am I the sole mobile developer? And that's not quite right. So I'm a technical lead. We have 3 teams. We're divided into, so going back, I mentioned we have KPI-based brainstorming. So when we have identified a few different areas that we want to develop, we have 2 teams that are outsourced contractors. They are in Ukraine. They're great guys. So we have 2 teams there, and they will work on one of these areas each. And we have a 3rd team that's split between New Zealand and London, and they work specifically on interactions between boat devices and the mobile app. So these are quite often quite low level interactions in C++ and the like, because when we're talking about systems that are, for example, streaming data for mirroring the chart plot on the mobile app, or these sorts of things. So a team's dedicated just to that area, and they're also working on some really exciting stuff. We have We have a watch app coming out, and it's very interesting there as well. Okay, how smooth is the user experience compared to native? So I actually find the experience on the app is actually pretty good. In fact, the major, I'll show you on my mobile just here. I've got a OnePlus, and you can have a look at my map. So here we are. You can nicely scroll. Ultimately, in terms of speed, oh, you probably can't see it, so it might be a bit too bright. Is it too bright? So you can see that actually the biggest issue in terms of performance is not the mobile app, it's network. So if you've downloaded offline tiles, the map performs excellently, and generally it performs well if you've got a good internet connection. You can be scrolling across just as if it's Google Maps. It's pretty much essentially. Yeah, I haven't found anything that's particularly slow. I mean, I guess we haven't done anything quite intensive enough to require native code yet so far, in that we don't have any 3D animations, for example. In fact, we're serving images essentially and interacting with data, so it doesn't, and phones are pretty powerful these days, so they can handle browser technology quite well even. So I haven't found any issue in that performance, but we do know that, for example, if with slower devices, there is a problem with React. React Native will be single core, which can be an issue if you have a slow processor. And one of our other teams has found that in some of their work. But yeah, we haven't seen problems with this. How do I deal with poor network signal for users out on the boat? So this is exactly the thing. The major point is being able to download map data. Once you've downloaded map data, you don't have to worry about your signal so much on the water, because you can see everything for the area you've downloaded, and we sort of expect people to do that. In general, we try to just not cause major issues. Ultimately, if you're out on the water and you haven't downloaded a map and you're trying to look at a map, we don't want everything to start crashing, but also we cannot give you the data if you don't have the connection, right? And this is certainly a problem. I think a lot of people expect the data to be available when it's not, and we occasionally get support requests from people far out on the water asking, hey, I'm out here, why can't I see this? And you know, and there's not much you can do really. Ultimately, if they haven't downloaded the data and they don't have a signal, then what can we do, right? Do we cache map data in advance? So there's multiple levels of caching. We use Cloudflare on the back end, and we have a variety of caching mechanisms, starting from Mapnik, which I believe caches things in memory on the client side, right? Yes, we have caching mechanisms, and in fact we're improving our caching mechanisms going forwards. And this is obviously important if you're scrolling around a single area, and we find that over 90% of usage will be in the same area. So caching is actually quite good and useful in this regard. Few people will just scroll randomly across the ocean, so you don't end up having the sort of imagined problem of needing to cache too much. Is battery usage something you think about? We do to an extent. We have the option of selecting different battery saving methods, and users, I haven't found many users use this, but it is something they genuinely worry about once they start losing their battery. I think one thing we have to be mindful of when developing things is we don't develop really intensive programs that run on the app, in that we don't want the apps, their phones to run out of battery. Because I think the first thing is people, even though people have the option, they won't like it if their apps start running out of battery, even if they're losing a setting that's high, that isn't battery saving. So it is, we have to be mindful of it when we're selecting what features we want to work on. And you know, there are many options where we could be doing things on the phone that we so far haven't chosen to do. So for example, auto routing is quite a complex calculation. If we did this on the phone, it's very possible battery would go down a lot quicker. Cool. That's all the questions so far. Any more questions?
Okay, it looks like that's it for the questions, in case we get any few more coming up in the moment. But thanks again for taking the time out tonight to obviously give this presentation, and the time to obviously get the presentation all up and running. Yeah, I'm sure if anyone has any questions, they can always drop me a message. I can relay it on to you. As I mentioned at the start, this is going to be on YouTube, on our channel. So if anyone wants to watch this back or share this with other people to discuss, feel free to do so. I'll put links in the meetup group tomorrow. But oh, actually, here we go. There's one more question. There you go.
Do we run the app in the background? I don't believe so currently. We are thinking of things to do with this in the future, especially when looking at notifications with regards to various things that could be happening about. And some of our apps do run in the background, but it's not something we do currently, I believe. Cool.
Okay, perfect. Yeah, like I said, I think that's it. If there is anything else, obviously I'll get it back. But yeah, as I said, thank you for taking the time out today, Michal. Really good to have you sort of give this presentation. As always, thank you for everyone as well attending, sort of taking part. If anyone does any topics they want to share themselves, feel free to drop me a message on, like I said, LinkedIn or the meetup group. Same as well. Obviously, if anyone's looking for new roles, feel free to reach out to me as well. But thank you very much, Michal. Good speaking with you tonight. And yeah, thanks again.